Hi everyone. Good morning, good evening, good afternoon.
Hi, Chaitanya.
Hello, Chaitanya. Good evening for you.
Thank you, Minaj. Thank you, Hema. So let's start today's discussion. Thank you all. Thank you everyone for joining the session today. So let's start the session today. Let me share my screen. Hope you are all able to see my screen.
Yeah, yes.
Okay. Yeah. So before getting into what exactly we are going to learn for the next 3 months, let me give you a quick introduction about myself. So everyone, this is Chaitanya. So I am your instructor for this R for Clinical Trials program. So I have around 14 years of experience in statistical analysis and artificial intelligence using multiple tools. So I started my career in SAS. So I used to work as a clinical SAS programmer. I worked for initial 4 to 5 years. I worked as a SAS programmer. Then I joined Indian School of Business for advanced management program in artificial intelligence and data science. Then I made a switch, and so I started working as a data scientist. So for the major multinational companies in multiple domains. So I worked in insurance, I worked in gaming industry, multiple industry, whatnot. So for the last 8 years, so I'm working as a data scientist. Um, so recently, I quit my job and I started a startup. So that is focused on developing artificial intelligence based products, especially in clinical trials. So I started my career in clinical trials, and slowly it transformed into a data science and artificial intelligence space. I thought, why not develop these AI based products in clinical trial industry itself. So that's where we launched our startup 4 to 5 months back, and currently we are building couple of products in HDDM and ADAM space. Um, that is a brief about me. So I have experience in SAS, Python, and R. After getting into data science industry, I worked especially now for 4 to 5 years doing the analysis, developing products, developing dashboards using Shiny. So that's where I thought maybe I'll devise a curriculum in which comparing SAS along with the R, so that it will be very easy for people to shift from SAS to R. I prepared the curriculum in such a way that whatever the techniques, procedures, functions, all the granular details in SAS, whatever you already know. So comparatively, I prepared that in R so that it is very easy for you to shift to R. Okay. So before getting into how do we learn this R programming, so let us do a quick exercise. I don't want to tell so many stories. I want to be as practical as possible. So that's why let's do a quick exercise and let's get into what exactly we are going to learn. So I believe all of you are from SAS, right? Anybody who is not having any experience in SAS? Okay. I'll take it as a yes. I think everyone is in SaaS industry only. Okay. So let us try to answer this. So there are two data sets. This is SaaS only. This is
Hello,
R.
can you hear me?
Yeah.
Yeah, this is Miraj. I don't have experience in SaaS in clinical industry, okay, but I know SaaS.
Okay, okay. Yeah, that is fine. That is fine. So anyway, we'll do a very in-depth learning in R. So for those of you who are from SAS, you will find it very easy to compare whatever the syntax that is in SAS compared with R. We'll do that exercise. But those of you who are directly learning R, don't worry, you can skip that comparison part. Whatever we discuss in R, you can learn from that. Okay?
Okay.
Yeah. Having said, so who will tell me this answer? If you know the answer, please just type in the chat box. I'll give you 5 minutes. There are two data sets, ADSL and ADLB, okay, which has two variables, unique subject ID and treatment TRT01P. In ADSL, we have only two records, and in ADLB, we have four records. Unique subject ID is common in both of them. In ADSL, we have TRT, and in ADLB, we have param. So we are trying to merge ADSL and ADLB. So see the code and tell me, so what will be the output? Okay. Yeah, note definitely we'll get, I agree. But what will be the output?
I think we'll get both records from ADSL.
Hi everyone, Junaid here. Sorry, Chaitanya.
Hi. Who's this? Sorry, I didn't see your name.
Junaid,
Yeah, hi, Junaid. Yeah,
I'm
thanks.
sorry for joining late.
Yeah, no problem. We just started the exercise with SAS. We'll slowly get into R. I just want to discuss why it is important to learn anything with the core fundamentals. I want to discuss that concept. So that's why I've given you this exercise. Can you, I want the actual values. I agree. It's two observations and four variables, whatever it is. So can you write those observations? It's only hardly two records, right? Can you just put, so it will be three variables, right? It is not four variables. It will be three variables because unique subject ID is the common thing. Okay. Three variables and how many records? If you know those records, can you write? Can you write them? Okay, somebody is saying six records. Okay. I'll just give you a couple of minutes. After that, we'll discuss. And also there will be three records. One is from ADSL and another two is from ADLB. Okay. Mano says it's only one record. Why one record? We'll have 8 records in the final. Okay. So it is data step. For those of you, we are not using ProcSQL. We are using data step. Okay, let me open. 4 records and 3 variables, Satish. Okay. 3 variables and 4 observations. Yes, absolutely. So can you tell me at least, so what will be the values for TRT01P for the 4 records?
Sorry, can you come again, please?
Yeah, I agree that there will be 3 variables and 4 records. I want the values for TRT01P.
I suppose all.
Oh. So it will be 4 values, you agree? So somebody said BRV 100 all. Okay. Subhan says all. Okay. I'm just expecting at least one right answer. Just try to give it a thought. So what happens in PDV? What is a PDV? You all know, right? Program data vector.
Yeah.
Yeah. So if something is changed in a PDV, so whenever one variable is read by merge, what happens? Do you know that it will be by default retain attached to it? Anyway, so let me show you.
Yeah.
Yeah, if something is changed, what happens? The value will remain as it is. Okay, let me run you the code and show you. So the same thing here, I've just written the code. So if I just execute it, yeah, can you see the output? The first observation is 101 BRV 100 and ALT, that is fine. So whatever the if statement we have written, so that condition will be satisfied in the second record, right? Wherever the param is equal to AST. So then what did we ask SAS to do? We asked the SAS to make it missing, TRT01P missing. In the second record, it was missing. So, but since it is read by merge statement, it is by default retained. So whatever the values that are coming after that, so it cannot change it because the value is already changed in PDV. Once it is changed, you cannot change it back, right? You are not reading that record again. Are you reading it? No, right? We have read that record already. There is no way we are going to read that record again. So that's why the value will be BRV 100, and after that 3 records it will be missing. Okay, so I think most of you use retain statement a lot, but there is this implicit thing which happens in SAS. Whenever you read anything by set or merge, it will be by default using retain statement in the backend. So whenever it is using retain statement, whatever the value that is there, it will be retained all across. Okay, so since you have only 2 records, how many records we have in the first data set? You have only 2 records. Once those 2 records are read, there is nothing to read again. So what happens? That second record will be there in that PDV. Okay, so once you actually change it in the PDV, it will be retained. Okay, is that clear, everyone?
Yeah. Chaitanya,
Yeah.
can you keep ADSL in the left right side in the merge statement and run once?
Okay.
ADSL on the right side.
Okay. ADLB. Okay.
Yeah.
It will be the same.
Same.
Yeah, it will be same because
Okay.
see, typically what happens is, so in SAS, so one record will be at a time, PDV can hold only one record. So first record will be read from ADLB, and at the same time, first record will be read from ADSL, and it will be merged and it will be given to the output. Okay. Again, the second record will be read from ADLB and second record will be read from ADSL. So in the third iteration, there is no records left for ADSL because nothing will be read. It will be just stored in the PDB. Whatever stored in the PDB, it will be just given as an output. Okay, that is why this thing is happening. Anyway, this is not a session. But I want you to understand the importance of understanding or so digesting these fundamentals, so that once we understand it, right, you give me any complex code, I'll be able to debug and I'll be able to develop. So always understanding fundamentals, it is very important. Okay, whatever we learn. So we'll follow the same principle in R as well. So in SAS, whatever the PDB concepts, I think it's a long time, maybe. So that's why some people who are not able to answer, but that is absolutely fine. So the reason why I have given this quiz is to just show you the importance of understanding the fundamentals. So we'll follow the same procedure in learning R. Okay. So what we will do is we'll do very deep dive into fundamentals of R. So whether it is about data structures, whether it is about reading, writing, doing any manipulations, whatever it is, we'll do very deep dive into the fundamentals of R. And whatever we do, we'll do a comparative learning with SAS. So for example, in SAS, every line, whatever the executed line, every line will end with semicolon. But in R, there is nothing like that. Okay. So in SAS, everything is bounded between data step and run step, right? Whatever we do, we'll do in either data step or in proc step. Okay. So there is nothing other than that. But in R, you can create variables outside any function. So we'll slowly understand that. Okay. So like that, we'll do each and every small detail in SAS, how it is implemented in R. We'll do that. And I strongly believe learning is something which will be very effective when you do problem solving. Unless you solve the problem, your that learning curve will not be grown. So whenever we want to learn something, maybe we'll listen first. After that, when we do it, then only we'll really understand what exactly is the concept. So my emphasis will be on the problem solving along the course completely. So in every class, what we are going to do is we'll break down the entire concept, entire curriculum into small bite-sized concepts. So suppose, let's say, when I give you a simple analogy in SAS, suppose, let's say we learn merge. Okay. So in merge, maybe left merge, right merge, different types of merging and all we'll learn. So once we learn that, so what we will do, we'll do some exercises. Before getting into any new concept, we'll definitely do in-class exercises. So then only we'll understand the intuition behind any concept. So that's why I have structured this class in such a way that every concept, once we learn it, we'll have a simple exercise. We'll do it. Then we'll proceed towards the next concept. Okay, we integrated seamlessly the theory and practical exercises. We'll have in-class exercises as well as hands-on learning. Assignments as well. Okay. Okay. Yeah. So we'll, like I said, we'll learn all the intricacies of R. We'll do SAS to R comparison. And one more important thing is, so my objective is not just to teach you how to use R in clinical trials for developing SDTMs, ADAMs, and TLFs. That is not only the sole objective of mine. So I want you all to be equipped with the latest trends in clinical trial industry. So whatever people are doing the innovation work, right? I want you all to be part of that. So whether it is developing Shiny based dashboards or whether it is developing some R packages. So I want you all to be equipped with those latest trends. I want you to lead the innovation in clinical trials. So once you complete the course, I want you all to equipped with these skills so that you can, along with the regular work you do, like the SDTMs, ADAMs, and TLFs development, I want you all to develop something cool and develop something new. Okay. So overall, our content, it is strategically structured into two phases. Phase one. So phase one is more concerned about what is R, what do we exactly do in R, so why do we use R, so what are the different fundamentals, different data structures, how do we store, etc. It's all about R fundamentals uh, specifically. So in phase two, what do we do is we specifically focus on how do we implement in clinical trial reporting. So whether it is STDM development, ADAM development, TLFs. So we want to master the different libraries we have. I think most of you know, right? The companies like Roche and I think there are few companies which are developing these packages and they are validating it. I'll show you in a while. So we will use all of those latest packages and latest programs which are there in R, which are people currently using in industry. So I'll explain you all of them and you will be equipped with those techniques. So in phase two, it's all about practical implementation. Okay. And also, so there are a few bonuses I'm going to give. So let me show you. Yeah. So how many of you know about GitHub?
I
Anyone?
knew, but it is like a repository, right?
Yes, yes. So it's like a something like so Instagram and Facebook and these communities are there, right? So for code related things and all, it's like online community of people who will share their code and who will share their open source work here. You can actually refer them and you can actually use based on the license. Some people will completely make it fully open source. There will be partial open source, something like that. So especially this Farmaverse is a very good a community in which they will give you all the R related codes, especially in SDTMs, in NADAMs, everywhere. So in this course, what we are going to do is we are going to learn how to access GitHub and how to clone any repositories. When I say clone, I'll show you quickly what does that mean. Suppose these are all different repositories which Farmaverse is maintaining. This is the famous library Admiral, which is maintained. So here, if you see, it is a modularized toolbox to develop ADAM datasets. It will have all the different functions available. If you want to get the code, source code also, so you can do it. In this course, we are going to learn how to actually get this complete source code to our so local system so that we can actually just use those R codes in our system. Okay. So simply, if I want to just get the complete code base to my system, I can simply use git clone. So all these things we will learn. Okay. So the benefit is, so whenever they are updating. I think most of you know SVN. I think in industry
Yes,
use SVN.
version control.
Yeah, version control. So Git is similar to SVN. I don't know if in some of the projects clinical right now you are using or not, because back in 2015 when I left, I think people were using SVN only at that time. I don't know what exactly changed recently, but it is very similar to SVN. So what happens is you will have the version control for all the programs and all the different elements which are there in that directory. So typically in R and Python world, in typical software projects, people majorly use Git. Okay. I'll discuss all of these techniques. So first of all, we'll create a GitHub account as a part of our course. Then what we'll do is we'll create a small repository. So whatever we are learning, right? In every class, we will just push whatever the code we are doing to the online repository, so that whenever you want to showcase your R skills to the world, right? You can simply share your GitHub URL so that you can market yourself saying that, I know these techniques in R, and I can develop these dashboards, everything, whatever you do, I want you all to market it as well. Okay. So this GitHub, so I'll explain you how to do that and all. And the important thing is especially Shiny dashboards. How many of you heard about Shiny dashboards?
I've heard it, but I did not get what exactly the work profile would be for Shiny board. I
Okay.
think it's something like you present the data, something like that.
Yes, yes, yes. See, ultimately, it's all about, why do we need a dashboard? Typically, we want some kind of interaction with any tables listings. So typically, whenever we develop a static reports like, let's say, PDFs or RTF files. So suppose, let's say, when we want to understand a few things like change and play with the data, typically we need to write again code, right? So suppose, let's say, the analysis, whatever we have seen in that table, we want to change it. Maybe in different dimension. Maybe in one report, we are seeing it by age group. In another report, if you want to see it by gender, let's say I want to change that group. So every time I need to develop a new report, right? Instead of that, simply if I develop a dashboard like this, if you see here, see, this is ADSL. If I just change it, ADRS, the data will be updated. So something like this, and especially in plots, it will be much more easier. Suppose in ADSL, if I select site group, okay, I can see simply the distribution of this. I can hover over this. These are interactive plots, so interactive analysis. These dashboards and all typically in Shiny people. Yeah. So Shiny is very useful in developing interactive dashboards. So just imagine yourself developing these dashboards, how cool it will be at the end of the course. So especially for your own purpose also, suppose if you want to just check the distribution of data, let's say typically while developing SDTMs Adams, so before writing different if conditions, to map from, let's say, SDTM to Adam, we want to understand the initial unique set of values, whatever they are present in those variables, right? So typically, what do we do? Either we write maybe proc sort and nodeop and nodeop key, and just understand what are the unique values in that present. So we'll do it variable by variable manually, right? Just imagine if you just create a Shiny dashboard and just pass this raw data set to that, instead of writing the code again and again, just for exploratory purpose, right? Whenever we want to do any exploratory analysis, then Shiny dashboards are cool tools to have. Okay. So I'll take one, I think maybe once we get into actual curriculum, let's see, mostly I'll take 1 or 2 sessions on this Shiny apps as well, because what I see is in industry right now, I've seen a lot of people developing these dashboards, especially for medical reviewers or biostatisticians. So typically they are not well versed with programming, right? Whenever they want to do any analysis right now, they need to depend on SAS programmers. But if we develop some dashboards and give it to them, they can do some exploratory analysis on their own. Okay.
And in this, the path we will be giving in the backend, it will take dynamically. Once the data set updates, it will reflect here. Right?
Yes, yes. So basically, so once we get into Shiny, you will understand it very clearly. So what do we do is we just write a small code in the backend on. So let's say this is a drop down button, right? We'll write like so for this drop down button, take this variable or take this set of values, something like that. So for each and everything you are seeing in the screen, right? We'll write a small R code to pass some values to that. So good
Okay.
thing is you don't need to worry about too much about what do you say, the web development and all. That is the cool part. You just need to
Okay.
code something like a normal programming wherein a small differences will be there. So we'll
Okay.
understand that in detail.
Okay. Okay. It's like a template, and we need to just create data set or variable. We can
Yes,
choose.
yes, 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 absolutely. There is a template. In that template,
Okay.
each field you will pass the values,
Okay. Okay.
and also
Is this Shiny dashboard? Is it somebody has developed? Is a third party tool or what?
show Shiny is a package. I mean, whatever I am showing you is developed by somebody else. So this I didn't develop. I'm just showing you an example. Like this, we can also develop. So Shiny is a open source a package which let you to which will help you to develop all these applications. So once you develop, right, you can actually deploy in the web. So we will discuss all of those things in our class. At the end of the class, everyone, all of you, you will be developing at least a couple of Shiny applications, and I'll help you in deploying as well. So what happens is when you develop, it will be there in your system only. But what if you want others to see, you need to deploy in web. So that also I'll help you. Okay. Yeah. And also there are very cool packages which we are going to discuss. So suppose, let's say this is a table. Typically we see, right? So a typical demographic table. So we have these counts per placebo, low dose, high dose, etc. So we have these different analysis lines like number of subjects, what is the distribution in age, like that. So typically your PDFs will be static. So, but if you see here, so the moment you click on number of subjects, so it will show all these subjects. Whenever you want to validate, ideally in clinical trial industry, how do you do? So you check the corresponding listing, right? For each table, there will be a corresponding listing, and listing you will check, let's say if if you want to check any patients, who are those patients, etc. So what if somebody wants some review, and if you want to develop something like this, you can always do. So there are so many cool things in R you can actually do. Let it be Shiny dashboards, let it be interactive PDFs, let it be whatever the typical submissions we do, right? Like SDTMs, ADAMs, TLFs. Along with the actual submissions, you can always do some innovation in R. So the reason I am telling you all these things is it's not only the typical development, you can actually develop cool things like a typical software programmer. Okay. And we are going to learn all of them along with our SDMs, ADAMs, and TLFs. Okay. Okay, let's quickly see the curriculum. So in session 1, we are going to see introduction of R, its applications, setting up R and RStudio. By the way, I have sent you that blog, right? So we are maintaining one blog, clinical.uplearner.ai. So in that we are going to discuss all of the lectures. If you have any, if you are discussing any important information in the class, definitely I'll maintain one separate blog for that. So how many of you installed R and RStudio?
Yeah.
I mean, I already had this RStudio and R like 3 months back. I have installed. Is this a change in the version there, or it's all good then?
I think version is fine. I mean, if you want to just update it, we can update it. Yeah, not a problem. If some version is installed, right, that is fine. Yeah, Vinay. Yeah, sure.
Yeah, even I installed long back RStudio.
Okay, okay. Yeah, I thought you have some question. Okay, no problem. Yeah, yeah. Okay. Okay, those of you who didn't install, I'm just giving you my blog detail in the chat box. So it's clinical.uplearner.ai. You can go to this blog. I have created one article in detail what exactly you need to do and all. So you need to install actually two things. One is the base R and the interface part, which is RStudio. Okay. So in the okay. Okay.
Installed RStudio and R is separate. I need to install again, or Studio
You
will do.
directly installed RStudio.
Yeah,
So ideally it will be first R,
I think.
and on top of that RStudio you need to install. Maybe I think it asked you to install that. If you try to install RStudio, it will ask R as well. You
Yeah,
might have done that.
might be installed.
You might
I
have
think I need
installed.
to check in my software.
So basically, R will be not having. You typically we use SAS Studio, right? SAS, whatever it is. So it will
Yeah.
have a place to store the data sets, place to see the programs, log, all those interactive windows will be there, right? If you want the same experience in R, you need to install RStudio. If you let me show you quickly. If you just install R, then it will be like a typical command prompt in Windows or in Mac.
But after installing RStudio, can we remove R? Because
No, 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 no. See,
we
think of
can't remove
R
it.
is like the base which does all the calculations. Okay. So since even in R you can do the programming. Suppose let's say, so this is R. Okay. It will
Okay.
have nothing other than this console. Suppose let's say A equal to 3, a simple A. Okay.
Okay.
Again, if I want to know the A, see the problem. The program, typically when you write a program, you will write some comments, you will write some statements, etc. Right? So you want to
Yeah.
actually format it in a nice way, but you can't do that in a console. In console, you can do only the calculation or only the execution part. If you want to store it in a proper, let's say, a text file, you want to write all those comments. Here also comments I can write. So the problem is,
Okay.
so this is like a comment. If I execute this, but in the below that comment, if I want to write something, I can't package everything in a proper form. Also, if I create something and I want to view, like in SAS, once you create a data set, you will view the data set, you will try to filter the data set, everything, right? Those kind of operations you can't do with the base R. Okay. So
Okay.
just think of like base R is actual package which does all the calculations. On top of that, you have an interface, a beautiful interface to show you what are the data sets created, what are the variables created, what is the program you are writing, what are the errors you are getting, everything. So in a proper SAS-like format. Okay.
Okay. Okay. It's a front end, RStudio. Okay.
Yes, yes, it's a front end. Not only R, yeah, in Python, in Java, everywhere, in typical programming languages, what happens is you have a base version and you have multiple IDEs. So these are called as IDEs, interactive development and integrated development environments. Okay.
Okay. Okay.
Yeah. So that's why you need to install R as well as RStudio. This is R, which I'm showing you. So I'll show you RStudio. So this is RStudio. So RStudio is similar to SAS, right? So you have a place where suppose I want to create an R script. So I can create an R script A equal to 3. So the same thing if I do here. So suppose there is a shortcut, Control Enter. Anyway, I'll discuss in detail in future classes. So if I execute this again, you can see in console below. So this is only one line, but if I run it again and again, it will be executed those many times, right? My code is preserved. So the same thing, suppose, let's say I execute it again. If I show you this console, so it will be printed multiple times, those many times. Okay. So this is where typically RStudio will have 4 different windows. You will have main window in which you will write a code, and this is a console. Just like console, you can think of like a log in SaaS. In SaaS, the log window is there, right? Whenever you see what is executed and what are the errors, all those things you will get in a log, right? In the same fashion, in R, you will get in console. Okay. And in SaaS, you have something called, I think, if I'm not wrong, a file system will be there, right? Whatever the data sets you developed, output window, I think, right? There is something called output window in which you can see the values, what are those which are created, everything, right? So you can see in environment. And one main thing that is fundamentally different between SaaS and R is in SaaS is like a closed source, right? Whatever they develop, they don't showcase that code or source code to you. You just use that particular functionality. Whatever that new procedures that will come, they will just give you with, let's say, proc, there will be some name, and you will use that. And you are not worried about whether it will work properly, whatever the backend calculation they have developed. Suppose, let's say, a simple example like linear regression. So if you are running a proc reg and you are doing that, you are not worried about what exactly they are doing in the backend, right? What is the algorithm they are using? Because they have done that rigorous testing and they freezed it for you. But the problem with open source thing is you need to do a thorough research about whatever the packages you are using, because these are developed by open source community. So if I just show you what exactly that means, if I just show you one of these, yeah, if you see this particular package is developed by these many people. I think it's loading, but yeah. See, these many people, all these people are writing code. And you are using whatever the code they have written. Okay. So these many people are developing it. So it is good in one way, because it's like instead of one brain working on a particular development, you have multiple, what do you say, people in the open source community. They are day in, day out, they are trying to come up with a new methodology, very easy way of executing the things. So that is very cool part, especially in open source. So what happens is, previously, if you are writing some 20 lines or 30 lines of the code, what they'll do is they'll create one package or one function for you. Whatever you are doing, it will be automatically happening in the backend. You will be writing just one line of code or 2 lines of code. So like that, day in, day out, they will come up with some new functions and new methodologies, which will make your life very easy. Trust me when I say this, especially in artificial intelligence world wherein I am working. So previously, I still remember 8 years back when I started my career, I used to write like for a particular AI model building, I used to write like 100 lines and 200 lines of code. The same thing nowadays, because of the new libraries and new methodologies they are developed. I think it's hardly with 10 to 20 lines I could able to achieve the same result. So even in R, people are, so this Admiral is maintained by, I think, majorly Roche people, Roche, what do you say, clinical scientists or whoever it is. So you can see last month, 2 years, you can see whatever they are developing. Okay. So this is the major difference between SaaS and open source like R. What happens is, so this is maintained by open source people. So when we say libraries are nothing but, instead of you writing manually the entire code from the scratch, line by line, they will make your life very easier. Okay, what they'll do is they will develop some functions. You will understand all these intricacies slowly. But trust me when I say this, because of these libraries, maybe in the initial stages it will be somewhat difficult for you to understand and just to move away from SAS methodology to R, but slowly you will understand the beauty of it. So in SAS, if you are writing some 10 to 20 lines of code, trust me when I say this, in R, hardly you will write some 3 to 4 lines of the code. It will be very easy also. Once you understand the fundamentals, right? So like I said in the beginning of the class, once you understand the fundamentals, maybe understanding fundamentals will take time. I'll spend a lot of time in fundamentals so that so in the class itself you understand everything and will practice exercises, everything. Once you understand the fundamentals, right, it's just a cakewalk for you. You are going to just um, let's say you're going to just take some code developed by others and you can use it in order to you everyone, you agree with me, right? Writing code is better than understanding others code. We have faced that multiple times. If you want to understand it, you need to know the fundamentals in very depth, otherwise it will be very difficult. So what we are going to do is, because since R is an open source, we need to have that fundamentals in place. Once you have that fundamentals, it is very easy to pick any code that is available in the market and use it for your own purpose. So after this course, you will not be completely doing everything from the scratch. You will have that confidence to pick anything from the net and use it for your own project. Okay. So I think people have asked a break. Yeah, since it is half time, let's take a quick break, 5 to 10 minutes, and we'll connect after that. Okay. Let's continue our discussion. So like I said, so this is the curriculum. We are discussing what we are going to discuss in our curriculum. So we'll have the overview of R and its application and basic R syntax. So in SAS, we have only data sets, right? Whenever we work in SAS, it will be always about data sets only. But in R, you will have multiple data structures. When I say data structure, if a data is stored in the form of rows and columns or observations and variables in a tabular format, we call it as a data frame or a data set in R. So, but there are other data structures. How do you store the data? It depends on multiple data structures. We can store it in vector, we can store it in matrix, we can store it in a list. Okay, we have a lot of data structures in R. We are going to discuss all of them in detail. So then, like I discussed, we'll be discussing about different libraries we have. So in especially clinical trial scenario, we will be using majorly tidyverse. Uh, tidyverse will have a lot of manipulation techniques like transposes, like sorting, joining, all those things are part of tidyverse. And sorry, there is a ggplot too for developing visualizations. So grammar of graphics, which is very famous, even in Python. First they developed in R, and after that they kind of developed in other languages as well. So ggplot2, it is very easy to use and you can develop beautiful visualizations. Along with that, we'll have other libraries like I've shown you, Admiral. So there is a tplayer, there is a teal, so many other packages we'll discuss. So each package has some benefits and some use cases. Like in Adam, you can use some, and for TFL, so we can use other like that. So we'll discuss all of them in detail. So then when it comes to basic programming in R, like how do we write these if-else conditions, for loops, while loops, how do we create functions? So typically in SAS, you have something called these macros and all, right? Wherein you can actually create the macro variables and uh, 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 actually just like a template you create and you can use it in multiple cases, right? In R, you don't have anything like that. You have something called functions. So with the functions and packages. If there is a template kind of a structure, you can actually develop few functions and store it in a package and you can use it afterwards. So like that you can do. Okay. And so advanced operations, functions, how do you handle errors? So there is something called error handling techniques we will discuss. And data manipulation, like so missing value imputation, data transformations, how do we select, how do we filter, how do we mutate, these things we will discuss in detail. Basically all the data manipulation basics we will discuss. And so joining and working with strings and dates, so we'll discuss about that. And complex data manipulation challenges and handling larger data sets, real world data processing exercises, and statistical fundamentals also we'll discuss. So basic descriptive statistics. And also I'll discuss about hypothesis testing or inferential statistics also. How do we carry out these descriptive as well as inferential statistics in R? We will discuss about that in detail. And visualization, like I told you. So we'll discuss in detail about ggplot2. How do we create these different plots like scatter plots, histograms, bar charts? Okay, all of these things we will discuss. And there is something called Plotly, which will help you in building these interactive visualizations. So like when you move a cursor, it will show the value. So all those interactions you can actually achieve with Plotly. We will discuss about that. So then we'll get into Shiny. So basics of building Shiny apps. What is the user interface? What is a Shiny server? What are the different components of it? Interactive widgets, how do we build? And reactivity components. So suppose when you hover over the mouse, this is what it needs to show, something like that. For each reaction also, you can code it in the backend. So we'll discuss all of them in detail. So then advanced Shiny development also will do, like integrating the other libraries and deploying Shiny applications. And finally, we'll do a small project. Okay. So on data processing, analysis, visualization, all these things. So this is I've included in the phase one. Okay. Phase one is all about understanding R compared to SAS and how do we do all the things which we are doing in SAS. Along with that, some additional things which we can do in R, like this dashboard building, these visualizations, and whatnot. There are so many things you can actually do in R. We will discuss in the phase one. When it comes to phase two, it is all about how do we implement whatever actual clinical trial submissions. Okay. So in the phase two, we are going to discuss initially the advanced libraries we have. One second. Yeah. Advanced libraries we have, like I discussed, Admiral, Tplayer, those advanced libraries, which current day clinical trial community is using for developing SDTMs, ADAMS, and TLFs. We'll discuss all about that. And I'll help you with GitHub. How do we maintain the source code? Because especially when it comes to so the development of these R codes and all, right? It is very important to know how do we maintain the different versions of it. And how do we use, you should not reinvent the wheel always, right? Somebody might have already developed something. How do we make use of that? And maybe whatever that is needed for our a specific project, we can add those functionalities to whatever already they have developed. So you need to be always checking the open source community. So regularly, what are the new things they are developing, and just clone them to your system. Okay, just copy the entire code base to your system and work on that. You should be able to do that. That is a must and should requirement. So we will discuss about that, and we will try to use these open source libraries and open source codes as well from the internet. Okay, then in the final 6 to 7 sessions, so we'll discuss hands-on development of SDTMs, ADAMS, and TLFs. So we'll take one study. What I'm planning to do is, for a one particular study, I have simulated the entire data for SDTMs, ADAMS, and TLFs, especially the raw data I've simulated using ChatGPT. So we don't need to worry about what do you say, these licenses and all. So we'll do end to end a small study, so which has at least 3 to 4 ADAMS and a few few SDTMs, few ADAMs, and few TLFs we'll develop. Okay. So content delivery, coming to content delivery. So I think I've shared you the LMS link with all of you, right? It's the same name as our company. It's uplearner.ai. Once you log into that uplearner.ai, you can actually go through the video recordings. So yeah, daily after the completion of the class, we'll upload them in learning management system. So whatever the hands-on exercises, assignments and projects, everything will be present in LMS so that so you can refer them back anytime. So it's a lifelong access. So once you have given the access, you can check the recordings lifetime. Okay. So like I said, this is planned in such a way that in the class, after every 15 to 20 minutes, typically, once we complete a small atomic concept, so once that is finished, we'll do some in-class exercises so that we'll get the intuition. So once we understand the concept in detail, then we'll move towards the other concepts. So like that I have planned. Once we complete this entire class, then I'll give you one assignment. So you need to do it before the next class so that our learning, this cycle is completed. So whenever we learn something, we need to apply it, then only we will understand it completely. So I want that cycle to be completed. Once it is completed, right, a lifelong, even after 5 years or 10 years, if I ask you, you will be maybe you will forget the syntax. Syntax is fine. Syntax, even if you forget, that is fine. But the concept, right? What happens in the backend when you execute this? How exactly are things? If you execute something, what exactly happens in the backend? If you understand that and if you apply it, then trust me, it's a cakewalk for developing any complex projects. Okay. So we'll follow that same methodology and we'll learn all the concepts in a very practical way possible. Okay. Well, and lastly, I've told you, right? Every one of you will be creating a GitHub account and you will be creating these repositories. And whatever the work you will do in the class, whether it is a small assignment or a small project, everything you will showcase in GitHub. You can actually, once you develop it, right, it's a very good way to market yourself in industry. So you can share your GitHub URLs with the people, and it will be so cool because typically, unlike software industry, in our clinical trial industry, typically very few people maintain these GitHub accounts, right? That will definitely set you up apart from the industry. So that's why I'm planning to make you all equipped with these tools. Okay. So mostly I'm thinking, so phase 2 and phase 1 combined together, I think it will take around 3 months. Okay, mostly it will be like close to nearly 2 months or so. It will take for phase 1 and phase 2, I think around 1 month, roughly around 3 months we will take.